Hi everybody, today we're talking about matrices of relations. A matrix of a relation represents the connections between elements of two sets, where rows correspond to elements of the first set and columns to the second set. It is typically a binary relation, meaning each entry in the matrix is either a 0 or a 1, indicating either the absence or presence of a relation. Let's start by looking at a relation from A, 1, 2, 3, to B, which is x, y. We'll let R1 be the set 1x, 2y, 3x, and then R2 will be 1x, 1y, 3y. For R1, the matrix has rows corresponding to A, which means the rows represent 1, 2, and 3. We put that together with B, which is x and y. We'll put a 1 in the matrix anytime there's a relationship between the row and the column, and then we'll put a 0 if we don't have a relationship. We'll start by just putting in all the 1s. 1x says we put a 1 in the first row, first column. 2y says we put a 1 in the second row, second column. Then 3x says you put a 1 in the third row, first column. The remaining entries are zeros to show they don't have a relationship. Let's do the same thing for R2. We'll start by putting in our matrix, then we'll add in our rows and our columns. This time we have 1x and 1y, which says both the first and second entries of the row get a 1. We don't have anything that starts with 2, so we'll move on to 3. 3y says put a 1 in the third row, second column. Now that we have all of our relationships, we put zeros everywhere else. Let's look at what happens if we flip the order of our sets. So now we'll go from B equals xy to A equals 1, 2, 3. We'll use the relations R3 is x1, x3, y2, and R4 is x2, y1, y2, y3. This time when I make my matrix, the rows are coming from B, so my rows are x and y. Now my columns come from A, which says that's 1, 2, and 3. When I look at my ordered pairs, I have x1 and x3. That says I put a 1 in the first row, first and third columns. Then I have y2, which is second row, second column. Then I put zeros everywhere else. For R4, I again start my matrix with my rows xy and my columns 1, 2, 3. I have x2, which is the first row, second column, gets a 1. Then y1, y2, y3 says I have a 1 in every entry of the second row. I'll put zeros in my last two entries. Let's do one more example with a bigger set. We're going to use S is 1, 2, 3, 4, 5, and we're going to do a relation from S to itself. Our relation R is going to be the set 1, 2, 1, 4, 2, 2, 2, 5, 3, 1, 3, 3, 4, 4, 4, 5, 5, 2, and 5, 3. In our matrix, the rows and columns both come from the set S. So our rows will be 1, 2, 3, 4, 5, and our columns will also be 1, 2, 3, 4, 5. I have two entries in the first row, 1, 2, and 1, 4, which means I have a 1 in the second and fourth columns. Then I have 2, 2, and 2, 5, which means I go to the second row. Then I put a 1 in the second and fifth column. Row 3, I have 3, 1, and 3, 3, which is column 1 and column 3. Row 4 has 4, 4, and 4, 5, which is column 4 and column 5. And finally, row 5 has 5, 2, and 5, 3, which is column 2 and column 3. Once I have all my 1s, I put zeros in all the remaining spaces. If you want to do a quick check of your work, count the number of ordered pairs you have in R and make sure it's equal to the number of 1s you have in your matrix.